Hello, and welcome back to Calero Academy. Today, we'll be looking at a quick question of the binomial distribution. So, as we can see here, this is a little bit of a squeezed version of the binomial distribution. Usually, we see it a little bit more stretched out, like the normal distribution. So, in this question, which is from the book Introduction to Mathematical Statistics by Robert V. Hogg and Alan T. Craig, the question asks us to bound the mode of the distribution, where the mode is going to be the value of x that generates the maximum point, the maximum value of f of x. So, as you can see here, what we're going to have to do is we're going to have to find some equations to deal with. The first equation that we're going to look at is that f of r, which generates the maximum value of f of x, will be more than the value just preceding r, the value just before of x, or f of r minus 1. Similarly, we're going to see that f of r will be more than the value of x preceding to it, f of r plus 1. So, from this, we can see that if we mix things around a bit, we're going to hopefully drive towards the answer. So, what we're going to do first is, let's divide over here. Let's make this equation 1, because this one will be a little bit easier to deal with, I think. What we're going to do here first is that let's divide both sides by f of r. We're going to get that f of r plus 1 divided by f of r will be less than 1, and that 1 will also be less than f of r divided by f of r minus 1, which we're getting from equation 2. So, if we remember the PDF of the distribution, of the binomial distribution, we're going to remember that f of x is going to be equal to n choose x times p to the power of x times 1 minus p, in brackets, to the power of n minus x. So, after a little bit of, a lot of arithmetic there, a lot of simple algebra, what we're going to get is that 1 will be less, 1, we're going to write it over here, will be less than p on 1 minus p times 1 on r plus 1 and times n minus r. I'm just simplifying things a bit from once we do a little bit of algebra. And in turn, 1 itself will be less than p on 1 minus p times 1 on r times n minus r. Okay, now what we're going to do is just simplify things a bit. What we're going to do is that, let's just, sorry about that. Let's get n minus r onto this guy. So we're going to just rearranging a bit. P on 1 minus p times n minus r on r plus 1 is less than 1, which is in turn less than p on 1 minus p times n minus r on r. Okay. Now, what can we do to simplify this thing a bit? How about we first start off with, say, multiplying both sides by 1 minus, all three sides of this equation by 1 minus p. I'll get rid of this guy, and we're just going to multiply 1 minus p to 1 here. So, that will lead us to that p times n minus r on r plus 1 is less than 1 minus p, which is in turn less than p times n minus r on r. Okay. Next, let's just go searching a bit for other things that we can do. N minus r looks like an obvious candidate because it's not going to be too hard to divide the middle bit by n minus r, and the rest will get rid of stuff for us. So, dividing again, we get that p times 1 on r plus 1 is less than 1 minus p on n minus r, which is in turn less than p times 1 on r. Okay. Now, the next obvious guy to hit with our axe is, let's axe the p's away from these two sides of the equation. That will get us that 1 on r plus 1 is less than 1 minus p on n minus r times p, which is in turn less than 1 on r. Okay, from here it seems like a pretty straightforward process of simplification. And now what we're going to do first is write it out. What we're going to do is simplify everything by switching everything around. By the laws of inequalities, when we switch everything around, we're going to get that r plus 1 is more than n minus r on times p divided by 1 minus p, which is in turn more than r. What we're doing here is noting the fact that, for example, let's look at this inequality. 5 is more than 3, which is more than 2. When we turn everything on its denominator, what we're going to see is that 1 on 5 is less than 1 on 3, which will be in turn less than 1 on 2. That's the principle that we're applying here. Moving up a bit. Now, let's try to make sure that there are no denominators here in this equation of ours. What we're going to do first is chop off the r's, because if we look at the thing we're driving towards, there are no r's in the outer bits of the equation. So that's going to get us that 1 is more than n minus r times p, which is in turn more than 1 minus p, which is in turn 1 minus p minus r, which is in turn more than 0. Apologizing again for that. So, now, let's get rid of the denominator over here. Let's multiply that out, and we're going to get that 1 minus p is more than n minus r times p minus r times 1 minus p, which will in turn be more than 0, because 0 times 1 minus p is 0. Okay, now, let's expand that, so 1 minus p is more than np minus rp, which is more than minus r, plus rp, which will be more than 0. We simplified things out by a bit, and now let's see what we can chop. Rp cancels out with minus rp, and we're left with 1 minus p is more than np minus r, which is more than 0. Okay. So, what we're going to try to see is, let's try to turn everything on its head again. We're going to multiply everything by minus 1, and that will switch the equalities again for us, and that's going to give us that p minus 1 is less than r minus np, which is less than 0. Now, this looks kind of close to what we're trying to aim at. We've got an r in the middle, so now let's get rid of the minus np. Let's add np to all three sides of the equation, and we're going to get that p minus 1 plus np is less than r, which is in turn less than np. Now, this is looking really promising for us. What we're going to try to see is, first of all, let's group this guy together. Then we're going to try to get into a format like this. So this is going to give us that n plus 1 times p plus 1 is less than r, which is in turn less than np. And wait a second. Let's see. Let's just scour our work for a little bit. 1 minus p. Yes. So. Oh, 1 second. There's just been a little bit of a mistake. Yeah, oh, sorry about that. This thing over here was a minus 1, so that's everything's right here. This is a minus 1 over here. So we have an MP over here, and now what we're going to try to see is, let's look up here. We're trying to get, on the left side of the equation is made for us already. We've got that done, but the right side troubles us a bit. We've got n plus 1p over here, and np over here. But what we have to see, that np is less in turn to n plus 1 all times p. And therefore, what we've got is our final equation. We've got that n plus 1 times p minus 1 is less than r, which is in turn less than n plus 1 times p. And there we can conclude the proof. This is just one. There are many more popular ways to solve this equation, of course. we'll be breaking this video into 2 parts, and in the next video, we're going to try to investigate another interesting format of this thing. Also, I should reference that this problem is similar to the problem that showed up in videos 17a and b. So thank you for watching this Calero Academy video, and we hope that you come back for more. If you have a question or suggestion for a video, please enter it into the comments. Thank you for